Okay, so let's give this a go. Now that I may have to fix this thing. We'll see what happens here. All right, so let's go through the strategy here, okay? If you guys need to familiarize yourself with that strategy, pull it up, okay? It's on your notes. It's the last page. It gives you 5 steps to follow. I'm going to go through those steps right now with this problem right here, okay? Now, the very first thing we always need to do before we start a problem is we have to make sure we mark our invisible exponents that are ones, okay? There's an invisible one on this 5. There's also one on this y. So I'm going to mark those first because the next thing we need to do, or the very first strategy we need to do, is our distribution, all right? This 2 right here, outside the first group, needs to get distributed to every base inside the group. There are 3 bases. So I need to distribute that 2 to every base inside by multiplying, okay? So this becomes 5 squared x to the what? Michael? X to the 6. Thanks for raising your hand. Y squared, right? Okay. Bless you. And then, I'll leave this in parentheses for just a second. We'll do x to the 6 times y to the 3rd. Okay? Now, are there any quotients or dividing we have to do? Yes. Where do you see division at, Sophie? Help me out here. Okay, that's fine. I just want to make sure we're on the same page. Now, do we have any bases we need to multiply? Yes. Okay. And how do we multiply them? Raise your hand, please, if you want to help me out. Okay. Sophie, how do we multiply bases? What do we do with the exponents? No, you're right. We have to multiply. You remember how we do? This is why we review our exponent properties here. Okay. All right. You multiply bases, you add the exponents. All right. So the base x's get multiplied, and we add those. We also do the same thing with the y's. Okay. 5 squared is 25. So we're going to have 25 x. X to the 12th power, y to the 5th power. And that's your final answer for this one. Okay? You have 1 base of each kind in your final answer. You only have 1 numerical base in your final answer. All right? And it meets all the criteria. All your exponents are positive. All right? So you can't stop simplifying until you have 1 base or every kind in your answer, and all your exponents are positive. All right? Now for the next one, I'm going to go a little bit faster on it. Okay? There is no distribution. Okay? But we do have an invisible 1 we need to take care of here on the z, and also here on the 18 and the 2. Now, since those are both on the numbers, those are both base or exponents of 1, we can just divide those as normal. Okay, so 18 divided by 2 is 9. Okay? Now, we have to subtract exponents when we divide bases. So we're going to subtract the x's, the y's, and the z's. Okay? So it becomes -5 minus -8 becomes 3 minus 3 for your y's and 5 minus 1 for your z's. Okay? These combine for a double negative. So -5 plus 8 is 3. So I'm going to have x to the 3rd power. Okay? Y to the 0 power. Z to the 4th power. Now, what is y to the 0 power? 1. So it equals 1, base 1. Okay? That's property 7. Know that property. Okay? So this really becomes 9 times x to the 3rd times 1 times 0 to the 4th. That becomes 9 x to the 3rd 0 to the 4th. And you're done. Okay? Any questions? If you haven't looked over your properties and done your work yet, you need to. Okay? Tomorrow is pivotal. All right? Yeah? Okay? Yeah, you got a picture of it, but you need to also be practicing this stuff too. Okay? That's why I give you that extra practice time with those multi-step problems on it. I actually just pulled those from an old test. Okay? No. I just pulled those from an old test. You haven't had a test over this stuff yet. Okay.
Oh wait, so these are going to be on the test?
Yeah, you have problems like this on the assessment and what we do today. Okay.
How many questions are on the test?
Oh, I think like 10. Okay. It's only 12, I think. 12 actually.
Each worth 2 points?
Oh, pretty close, baby. I have to look at it and see. I forget.
What's the total point?
Sophie, I honestly have to go back and review it. I don't know for sure. Okay. I think it's 25.
So it's actually.
So 11 questions worth 2 points and 1 question worth 3 points.
No, that's not the case. I know it's 12 problems. I think the first 6 are worth 3 points each. The next 2 are each worth 1 point. Next 4 are worth 1 point, and the last 2 are worth 2. And I give you 1 for free.
Oh, a 3 point.
A 3 point.
So we got basically.
There's 13.
Okay. Now we need to get working on this stuff right here. Today we're going to learn how to simplify expressions like this. Okay, the square root of 12. Now, you probably know, oh, I can do that. I have a calculator for that, right? Well, unfortunately, when you put that in your calculator, you get a decimal. And the bad news is for that decimal is that it never ends and it never repeats. So you can't get an exact value with your calculator. Okay? Because when we simplify these expressions in this room, I want exact values. So, I have a way to show you how to do that today, and I'm just going to go through it with you. Now, this is what we experimented with on Friday with the West House. Okay, so you're not out anything today by us just going through this. Okay, so let's go through it together here. Before we go over this expression, how to simplify it, I'm going to show you the best way I think to do it. Okay, then what we're going to do is go through some vocab because we have some things to discuss today. These are called radical expressions. All right, from this point forward. And we need to go through a couple of terms here, okay? The blue symbol, you've seen that before. You know that's a square root, right? Well, if you notice, though, there's a number in front of the square root symbol right here. This number I highlighted in green, right? You guys getting this down in your notes? Okay, good. All right. I know the answer. Okay? All right, so here's the thing. We call these radical expressions because they can be larger than square roots or smaller in some cases than square roots. All right. So the number that is highlighted in green here, we call this an index. Okay. Now, usually you're probably used to seeing no number there. That means a square root, correct? Okay. So if there's no number there, then automatically the index is 2 for a square root. Usually when you see an invisible number, you think it's 1, like an invisible coefficient before x or a visible exponent on the base, right? For a radical expression like this, if you don't see a number in front of that index, okay, then it's automatically 2. Otherwise, 3 stands for cube root, 4 stands for fourth root, 5 stands for fifth root. Okay?
How do you do fifth root?
Well, that's going to be another problem for another time. Okay?
Cube root, not cube root.
Let's not interrupt. All right. Now, that means then this blue symbol here is no longer called a square root symbol for our purposes. It's called a radical symbol. Okay? Okay? And the value underneath the radical symbol is called a radicand. You put the whole thing together, you have a radical expression. Or sometimes we just say a radical. All right? Like I could say, for the first one that says square root of 12, I can say radical 12 now. Right? They mean the same thing. Okay?
So you can say radical.
You can kind of swap out radical for square root.
Is this going to be on our test?
Mm-hmm.
You have to name these on our test.
Nope. But you need to know how I'm referring to them so you need to know what the parts are, okay?
Cannoli oil.
Oh, is that what the symbol with R and D on your calculator?
No, that stands for something different. That stands for radian then.
Are we gonna, is that gonna be on our test?
No. Don't worry about that. Okay, so we're going to go back to the square root of 12. I'm going to show you the way to simplify that. Okay, the easiest way, I think, is to simplify that. Okay? Now, if we, like I said before, if we had extra time, I would have you guys like work in your groups and come up with a way to simplify this. But we don't have that time. So here's what we're going to do. Okay? There's two ways to do it. Okay? But it's over the years, it's been an overwhelming majority of one method over the other. Students prefer one method over the other. So I'm going to show you the preferred method here. Okay? Now, if you don't like that method or you think you want to see the other one, we can talk about it after the fact. Okay? But for this method, you have to know your perfect square values. Okay? Like, for example, you have to know 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay? All right? What those all represent. All right? Here's the idea. The square root of 25 is what?
5.
5. Okay? Now, check this out for a second. Okay? What are two numbers multiplied together to get you 25?
5.
Okay? Yeah, 5 and 5, right? That's why that square root becomes 5. Let's try another one here. Let's do 16.
4.
It equals 4, right? So, what are two factors that are the same to give you 16? 4. This becomes the square root of 4 times 4. I can write that as 4 times 4, right?
No.
Isn't 4 times 4 16?
I'm gonna guess.
Okay. There's a rule from algebra that you haven't studied yet. That you will in algebra 2 when you study radical expressions. So I'm taking a little bit of grace here, okay, showing you this because I know that it's mathematically allowed, all right? There's a rule that says if you take the square root of a product of terms, that also equals the square root of each individual term multiplied. So I can split the product into individual radicals and multiply them together. Okay? Now, what is square root of 4? 2. So this becomes 2, and this becomes 2, and this becomes 4, right? That's how we get those to match up. They match up now. Are we good? Why is that important? Because we're going to do the same thing over here on the other side of this line with the square root of 12. Okay? What you have to get is a factor pair of 12 where one of the factors is a perfect square number. Okay? So I need you to raise your hand if you think you found the pair that works for 12. Okay? And if you can't find a pair where one of the numbers is a perfect square number, then it's simplified. Otherwise, you can simplify it farther. So is there a factor pair of 12 where one of the numbers is a perfect square number? Sophie had her hand up.
3.5.
No. Try again. Not 3.5.
3.5.
No, 3.5 squared is not 12, dear. We're not trying to find half of 12. I need to know two numbers that multiply to 12. Okay? And one of them is a perfect square number. One of those in that list of perfect squares. You want to try again, Sophie?
No.
Okay. Marat. 3 times 4. Perfect. That's what I'm looking for. Okay? All right. So here's how we're going to do this. Okay, the square root of 12 equals the square root of 3 times 4. Actually, I'm going to do it 4 times 3. It doesn't matter. But I like the perfect square factor first. Okay? Now, split. Okay? Equals the square root of 4 times the square root of 3. Now, what is the square root of 4?
2.
That was 2 times the square root of 3. We can't simplify the square root of 3 any farther. Okay? That's as far as it gets. So I multiply those together. They're not necessarily the same, so I just mash them up. Okay? Your final answer for this radical is 2 radical 3. That's the simplified version of the square root of 12. To simplify a radical expression, okay, when it's a square root, you pull out all perfect square factors of that number. Okay? And that's how you simplify a radical expression. We're going to do it again. Okay? The hard part here is knowing your list of perfect squares. 1, 4, 9, 16, 25, 36, 49. and so on. And knowing which one or ones, you want the largest one, okay, that can divide your given number. Okay, you figured out that puzzle, the rest of it falls into place pretty quickly. Okay? Let's try a couple of examples here. We'll do these together while you guys are still learning this little ropes here a little bit, okay? We'll start with the square root of 8. Okay? Get it down. Get it down. Get it down. We'll do this one together. We do a couple of these. I'll give you a chance to try one on your own, and we'll see how it's going, okay? All right, so Reagan, can you think of a factor pair of 8 has one number as a perfect square? You can't? Okay, that's fine. Ryan, can you? Answer my question. We're going step by step. 4 times 2. Very good. That's what I'm looking for. Now, help me out with this. You think you have the right answer? Help me out with it. So we're going to rewrite this as a product. 4 times 2. That's right. And you don't want to use 1 in your factor pair either. Okay? 2 radical 2. That's exactly right. Okay? So all you're doing is you're taking the perfect square factor out of the product, okay? And taking the square root of it, basically, is what you're doing. Whatever's left over inside the radicand gets multiplied together. And if there's any numbers outside the radicand, they get multiplied together. Okay? Right?
What if 8 times 1?
Yeah, but you don't want to use 1 because it's redundant. Because if you do 1 times 8, then you have square root of 1, which is 1. Times square root of 8, and you're back to where you started. You started out with the square root of 8, right? So you made no grammar. But square root of 1's 1, so you're back to square root.
But technically, it wouldn't work.
Technically, if you just
Technically, it
explained
would
it.
work.
You can do it, but it's redundant to do because it puts you right back in the same position you were at the beginning
But
of
it
the
would be
problem.
a correct answer.
No, it would not.
No. The square root of 8.
It would not be simplified because you can pull out a perfect square factor. So would that be considered simplified? Okay? All right. Now, I want you to try the next one, but we're going to do this in steps, all right? So I want you to just think of the factor pair that you need for the square root of 18. Just think. Okay? Don't write anything down yet. Just think. You want the largest perfect square factor of 18. Okay? And if you have to write down some things, write down some things. You can list your factors out if that's what you need to do. Okay? Do whatever it takes. No, 2 is not a perfect square. Okay? Who thinks they have a factor pair that's going to work on this one? Jack? 9 times 2.
Wait.
Murat, 9 is 3 times 3, buddy. 3 squared is 9, bub.
Oh, that's okay.
Okay?
I'm just confused.
That's okay. This is why we have to discuss this stuff, okay? All right, so we're going to rewrite this as the square root of 9 times 2. Okay? Can somebody tell me the next step? Right? Split them up. Mm-hmm. Yes. Good. Nice job.
Wait, how do you
Oh. Any questions? Any questions? Sophie? Are you sure? You were starting to ask a question. I just want you to ask it the right way. That's all. we can all hear what the question is.
She said, oh, never mind.
I heard you, but what did you just realize? Can you tell me what you just realized? The
She's refusing.
hey, as long as you're good with it, I'll let it go.
Yeah,
Good
I'm
with
good.
it? Okay. Let it go.
So,
It's radical by pretty much you know which one's at its lowest form because you would do it as whatever those are called. I can't remember.
2 has no perfect square factor greater than 1. It's simplified.
Yeah. but-
That's how you know.
The radical is the little check mark line.
Yeah, this sign right here is the radical symbol. So we say 2 radical 2. Or you can say 2 times square
How do
root
you
of 2.
know what's before the radical?
What?
How do you know what's before the radical?
So
This number right here, this radical 9, becomes 3, right?
Because
Well,
it's
it's
like,
3 times square root of 2. That just mashes together to give you 3
it's
radicals.
like, you know how the square root of 9 is
square
3?
of 9 is 3.
So then, like, you like, since it doesn't have the square root anymore, doesn't have the thing around it.
You just multiply, you just mash those together. Whatever's inside radicals, multiply together. Whatever's outside, multiply together. Just
Well,
mash
you're
that.
not really that good at explaining things.
Okay.
I know.
All right. For the next one, you guys try it real fast. Try it real fast. Square root of 24.
Okay.
Okay. Actually, yeah, let's just start this one. I'll give you a minute to work on it here. Square root of 24. Okay. And then we got one more to do. And then we got to throw something else in the mixture. Now, as you guys work this out, you need to think about this. There is another method I can show you on this. Okay? So if you're not liking, if you're having trouble figuring out what your perfect square numbers are, there is another way. The other way is to take the number that's the radicand, okay, in this case 24, and factor it using a factor tree. Okay? You ever guys do a factor trees back in a couple years ago, whatever?
Those are not helpful.
Okay.
Yeah, those just take
Bro.
forever.
It's a little bit more work on the front side, but it comes out, you don't have to do perfect squares that way. This way, you have to remember your perfect squares, but it works out easier after you know what the perfect square factor is. So you have to decide what's the trade-off. Okay? I don't want to show you method 2 unless you're really interested in it. If you are, I can show you individually. Okay? Right? You got an answer for this one?
Yeah, I want to see if this one's.
I'll check it. When you guys are ready for me to check, I can check it. If you're right, you can check your grouping.
I don't know about this.
That's not exactly it. Okay? You
Oh, you
find the wrong thing.
How did she get 3? This is what I got.
How'd
you get
Yeah.
4 times 6.
Yeah.
Is that right? Or no?
6 divided by 2.
Not quite.
Well,
Give me the same thing as number 2.
2.
Okay.
What?
So give me the same thing as number 2.
Oh, wait, yeah, it's 6, not 3.
Wait a minute.
See,
You did
I
it
know.
twice. Is 12 a perfect square number?
No, I quit that one.
So,
Is 6 okay. Well then, you have 4 here, right?
Yeah.
What's square root of 4?
2.
2. Does square root of 6 have any perfect square factors?
I don't really care. I don't want to be nice.
I think you've mixed it up a little bit.
Yeah, I think I did too.
Okay.
Actually, it's divided by 2.
That's it, Jack. Good job. Check. Marat, you got it. Okay, good.
You only got it because I.
What? No. I'm confused.
Right.
Dude.
That's it.
Yeah,
I got one right. Hey, Sophie, wait for
I'm
you.
sorry, Sophie.
I got
This
two.
shows
That's
you-
what I got. Twins.
Dude, oh my god.
It doesn't have
No,
perfect square
that's
factors. Right?
Mariah, you got 2.
Oh, okay.
Yeah, there you go. That's it.
I
Now,
got
good
3
It's
check
not even a
marks.
check.
I got the same thing at first. I got 3, but I got 3 check marks. Wait, how did you get 3?
job.
Because I accidentally divided by 2.
Find your perfect squares.
Instead of finding the
What's
square
the
root, I
what's
divided
square
by
Oh my god, stop talking.
2.
Yeah. So it becomes 2 times square root of 6.
Sophie.
Because it's not under
You're not
radical.
even fucking here. You're just like blocking one of your eyes.
This, here's the thing, this one doesn't have perfect square factors.
So I got.
Hey yo, Zach Sparrow here.
That was gonna stay inside.
Like, what are you covering your ears now?
Okay, you.
The one that doesn't have any perfect square factors.
I hurt your ears, so you can't
That's why
hear.
I suggest making the perfect square factors purple.
Sophie.
What is this?
Yep.
Dropping your head off. Sophie.
Kids, ready?
Yeah.
You gotta flip it around, Noah. Okay? You switched the wrong thing in and out. Check this out.
Yeah.
Okay? All right, so. I'm going to do it real fast. I saw everybody's work. Good job, everybody. Here's the thing. I would write the perfect square factor first, okay? You don't have to, but if you want to get to the habit where what's left over is at the right of your work, then write the perfect square factor first, okay? Just because the square root of 4 times the square root of 6, this becomes 2 square root 6, okay? That's it. This equals, I'll put these little marks here. This becomes 2.
This is just our test.
Oh, you have 2 problems like this on your assessment plus the exponent stuff.
No, not the exponent. Wait, so we're done?
No. No, I didn't say that.
We have nothing else to learn?
What do you mean? Oh my God.
Mr. Harris, would we reverse solve this one?
Nope. Do it the same way. Don't worry about the 2 in front until I tell you. Okay?
Okay, 75. What do you say? So 75. Oh! I found out.
Okay, so here's the thing. You leave the 2 on the outside until you multiply with it, okay? So keep the 2 in your work as you go through.
I'm not exactly.
Who has the factor pair that works? Raise your hand. Okay, Natalie? 25 and 3.
What about the 2?
I got it. I just don't
Wait,
know.
7.
Excuse me. That's not effective, okay? It's not productive.
Didn't you say the 2, like?
I said wait for me with the 2. I'll help you out with that at the end. That's what I said.
But it could be 300.
So we would still fully solve it,
reverse
right?
it.
Like even the multiplication we would solve.
So that would be 4. 4 times 75.
Check it out for a second. Hold on, okay? You leave the 2 on the outside. Do the rest of it as you have been taught, okay? Square root of 25, what's the square root of 25? 5. So then this becomes 2 times 5 times the square root of 3. Now, combine. Anything that gets multiplied together, multiply it together. 2 times 5 is?
10.
10. Radical 3 is the final answer.
I knew that.
I didn't know what to do with the 2. But now I know what to do with the 2.
Okay? That's it.
How many more minutes do we have left in here?
5, 7.
Not enough.
Yeah.
All right. Go ahead and talk about this one real quick in the groups. How do you simplify the square root of negative 40? Okay. Do it together. Okay.
So negative 40. So how do you do it?
You want the biggest single one. So then what would be that?
Oh!
I don't know what your is one.
Oh, it's 410.
Oh, yeah.
Yeah.
What would it be like?
Well, negative 4,
No.
yeah.
8 and 5.
None of those are
four
perfect
ten.
squares.
We can do 4 and 10. Yeah. So
It's 4 and
2.
10.
Okay.
Yeah, I'm right, and I'm always right.
Yeah, let's take one.
Don't forget I'm recording this.
You're recording.
Negative 4 and 10.
What is that? I don't know what that means. Oh, okay.
Our problem is I don't know if our volume is getting recorded.
Oh,
I've had
so
some-
maybe they're not hearing us right now.
I'm having some issues with audio.
Did you flip the bracket?
Wait, so can we like say anything right now and they
No.
won't hear us?
No,
I
did
can't
you flip the
guarantee.
microphone? That's right. It's
Man,
flipped.
guess what? Chicken butt.
All right. Do you guys have answers for me?
No, not yet. I'm a bit confused.
Okay.
Wait, never mind.
Okay. I ask you quick answers here. Okay. I'll take an answer from each group real fast. Or if you want to say an answer, that's fine too. No, it doesn't work.
I'm not gonna answer.
Ryan.
What?
Well, you don't know whether the two numbers would be negative or positive, so I'm just gonna say either negative 2 radical 10 or negative or 2 radical 10.
Okay.
One of those.
Okay.
Wait, but we're the right group.
Sorry.
That will also be our answer.
Yeah.
That's what Andy says.
Oh my God.
Good job, Andy.
Hannah?
I say negative 2 radical 10.
Okay. Okay, guys in the green group, you guys got anything for me? It's okay if you don't. Same.
It's already up there.
Sophie?
What group are we
See, I listened to what you said and said you had the same thing, so I went ahead and put it up there, okay? But I have the answer too.
He says negative 4. He says no school.
No school. Oh, let's go.
No school. I said that.
Stop.
That would make sense.
We're in a group. I'm supposed to
That's the
stop.
question, isn't it?
Okay.
No,
I think it's infinite.
Ever since
I know.
the past couple of days, you've been
No,
wrong.
that's not
Yeah,
even
exactly.
possible.
I just remember.
So it-
I want to hear from Marina.
My brain hurts.
Okay, Marina's going to tell us something here.
I'm pretty sure that negatives and the approximately don't go together.
She's saying that you cannot take the square root of a negative number. That number does not exist, and she is correct.
Wait, can we
Okay,
switch to no
Okay.
solution?
Everybody's going to switch to no
Please switch
solution.
to infinite
Okay.
without any solution.
So,
I want a keyboard.
here's the deal. This becomes something called, we had a little bit of discussion about this at the very beginning of the year. Square roots of negative numbers become what we call imaginary numbers.
Yeah.
They're not there.
Okay,
Sorry.
well, you got it wrong as
Okay.
well.
No,
So-
I got it.
If you see this on an assignment, you know this has no real solution.
Where's your dad?
Okay. So we're going to stop it there today. Okay. Your test is not going to be on Friday. It'll be next Tuesday.
Yay!
Oh, it's
I won't be here
90%
next
chance.
Tuesday. Me neither.
We have
Well-
a 10%
Oh.
chance.
Me and Hannah are going on
Where's
vacation
my
next
what
Tuesday.
to my cat?
Yeah.
At
He just
home.
walks back every day.
Why would I bring my cat to school?